Hello everyone. Today we are going to discuss about the friction chapter in kinematics of machines. I am Dr. B.B. Sangme. So initially we are going to discuss about the theoretical aspects of friction, and later on we will see the mathematical part of the friction. So friction, technically we can say that friction is the resistance to motion. So any object which will try to move, it will experience a friction normally towards the opposite to the direction of motion. So it is the resisting force which will oppose the motion. Okay. So there are various types of friction in the bodies which are moving. We can say that the sliding friction will be there, where two objects will slide over each other. Rolling friction will be there. The rolling friction is basically observed in case of the wheels which used to slide on the flat surface. Turning friction will be there. The friction which is observed in the links which will have the turning motion, like one link is turning about the axis of other. And there is one more friction which is called as static friction is also there. So static friction is the friction experienced by the body which is at rest. Okay. So why does the friction occurs normally? If you'll see any kind of surface under the microscope, the surfaces which seems pure flat. So consider this is the surface. To the naked eyes, the surfaces which seems pure flat to the naked eyes, but if you'll see under the microscope, there will be some crests, some ups, some downs. Okay, so consider this surface. So here if you'll see this under microscope, so you can see some irregularities will be there, some crests will be there, some troughs will be there. Okay, so consider this is the surface under the microscope. So you can see that some highs are there, some lows are there, some valleys are there. Okay, so this is the surface observed under the microscope. So if you assume that two objects are there, so here what I will do, I will draw the two objects. So consider this is the object. Okay, and one more object is there. Both are sliding on each other. Okay, the upper one is trying to move towards the right side, and the lower one is, or we can say that it is the stationary one. So this is the stationary one. Okay, the upper one is trying to move towards the right side. So this particular region is going to experience the friction, or we can simply say that there will be an interlocking of surfaces. So why does the interlocking occurs? As I already said that if you'll observe this particular surface under the microscope, there will be some crests, some troughs, some valleys. So irregularities will be there. Okay, so these are the irregularities under the microscope for this particular surface. And for this particular surface, again there will be irregularities present, there might be. Okay, under the microscope. Okay, so there will be interlocking of these crests and valleys due to the irregularities present. So this particular interlocking can be reduced by providing the lubrication. But we are going to calculate the mathematical expression of this, the magnitude of friction. Okay, so as I already said that this interlocking can be avoided by providing the lubrication. But how to calculate, the question is how to calculate the intensity of friction. Okay, so here once again I'm going to show a flat surface. Consider a flat surface. On this particular flat surface, I'm simply going to keep an object. So consider an object. So this is the object which I have kept on a flat surface. Okay. Consider W is the weight of the object. So this is the weight of the object which is acting towards the downward side. Okay. So here W is the weight of the object which is acting towards the downward side, and according to the Newton's law, every action has an equal and opposite reaction simultaneously. So there will be a reaction offered by the this particular flat surface towards the upward side. Okay, so here this is the reaction Rn offered by the flat surface which will act towards the upward side. So this is the normal reaction which will act towards the upward side. Now what I will do, I will apply a force of magnitude P towards the right side so that it is going to move, or I will try to move this particular object. So consider P is the applied effort. Okay, as I have applied a force of magnitude P, there will be a frictional force which will resist the motion of this particular object. So it will act towards the left side of same magnitude. So consider this is the frictional force F which is acting towards the left side. Okay, so mathematically this frictional force F will be directly proportional to the normal reaction, this particular normal reaction. Okay, if the normal reaction is going to increase, the frictional force which is resisting the motion of the object is going to increase. Now the normal reaction is actually depend on the weight of the body, which is W. As I already said that the reaction offered by the plane is exactly equal to the applied load which is acting vertically downward side, W, as per the Newton's law. Okay, and in practical life we have observed that the objects which are heavier one requires more force P to move that object, and the objects which are lighter requires less P or less effort. So we can say that the friction is directly proportional to the normal reaction offered by the plane on which the object is kept. Okay, and the normal reaction is depend on the load of that particular object. But as I already discussed that the friction is due to the interlocking of surfaces. There is one more factor which is called as a coefficient of friction. Mu is also the factor which affects the magnitude of frictional force F. So we can consider that the frictional force F is actually the product of coefficient of friction mu and the normal reaction offered by the plane Rn. Okay, so friction is depend on mu and Rn. Now how to calculate the F? It is the product of mu and Rn, as we know that, but here we are going to produce the relation between the applied force P and the frictional force F. So we are going to calculate how much amount of effort is required to move this particular, or what amount of effort is required to move this particular object towards the right side. Okay, so once again I'm going to consider a flat surface. So consider a flat surface. So here this is the flat surface on which I'm going to keep an object. So I have simply kept an object on this particular flat surface. Okay, The weight of the object is again W, which acts in the vertically downward side. As I have already said that the flat surface is going to apply an effort of magnitude, reaction of magnitude Rn. So consider Rn is the reaction offered by the plane. So as I already said that I am going to apply a force of magnitude P. Consider P a force which is applied on the box, which will move towards the box towards the right side. There will be a resisting force F, which will resist the motion of the box. Okay, so here what I will do, I will complete this particular box and I will draw a line, a diagonal line, which is going to represent the resultant of this particular F, this particular force F, and this normal reaction Rn. So this is the resultant, and consider this is the angle theta which is made by the resultant. Now the frictional force F is developed due to the applied force P. So it is the resistance to motion, but whatever the force applied P is, the magnitude of the force is P is very less right now. For this particular condition, the P is less than F, so the box will not move or the object will not move. Now what I will do, for the same object I am going to increase the force P. So once again here I am going to consider the same object. Okay, so this is the load W, which will act towards the downward side. Similarly, normal reaction offered by the plane. Rn, which will act towards the upward side. Now what I will do, I will increase the applied force P. Here you can see that I have increased the magnitude of the applied force P. Okay. Now what will happen? Once again, as we know that as per the Newton's law, the friction is going to increase. Okay, so here the frictional force F is again increased, which is the product of mu into Rn, as we have already discussed. Okay, so once again what I will do, this is the frictional force F. I will complete the box as I have already discussed in this particular figure. As the frictional force F increases, here I will complete the box. Okay, and here once again I will join a diagonal, and you can see that the inclination of this particular resultant force R is increased. So I will call it as theta, but yet the box is not moving. because whatever the applied force P, it is less than F, which is the product of mu into Rn. As we know that the mu is a constant value, which is the coefficient of friction, and Rn is the normal reaction offered by the plane, which is again we can see that as a constant value, and it depends on the load W. Okay, so what I will do, finally I am going to increase my efforts so that I will move the box. So once again, on the same flat surface, I will simply keep a box and an object. Okay, consider an object, the same object, its weight W is acting vertically downward side. The reaction offered by the plane again acts vertically upward side. Okay, now here I'm going to increase the effort P. You can see that I have increased the effort P. Okay, so there will be an now the applied effort P is I will say that here the applied effort P is actually applied effort P is now it is greater than F, which is the product of mu into Rn. Okay, now the frictional force F, there is a frictional force F which will act towards left side, but its magnitude is limited because it is the product of mu into Rn. Okay, so here once again what I will do, I will complete the box. So this is the box and I will join the diagonal. So this is the resultant force R, and this is the angle made by the resultant force. Now I will call it as phi, as a friction angle, or we can call it as the limiting angle of friction also. Obviously phi is greater than the previous angle theta. So the phi is the angle where the box or the object will move towards the right side. Okay, now we are going to discuss about the mathematical part of this particular phi, that is friction angle. So I will remove these figures. So the last one I'm going to use. Okay, so in the figure you can see that this is the frictional force F, which is equals to mu into Rn. So here if you'll see, phi is friction angle. Okay, so tan of phi is equals to, this is the frontal side which is parallel to the frictional force F. So tan of phi is equals to frontal side F, frictional force F, and this one is the adjacent side, which is Rn. Okay, so tan of phi is equals to F upon Rn. So tan of phi is equals to, but I have already discussed that in the previous derivation, sorry, in the previous part, that F is directly proportional to Rn and F is equals to mu into Rn. So if we put this particular value in this particular equation, then tan of phi will be equals to mu into Rn upon Rn. So the Rn and Rn both will get cancelled. Okay, sorry. So finally, tan of phi is equals to mu. So the friction angle phi can be calculated by using the formula phi is equals to tan inverse of mu. Okay, that's it for today's lecture. The rest of the part we are going to discuss in the next lecture. Thank you. Thank you very much.